Now we're looking at some of our exponent problems. So if we look at number 17, we have 6x to the negative 2 times 4x to the 8th. Notice there's no plus or minus signs in here. This is purely multiplication. So when we're multiplying, we can put the numbers in any order we want. So what I'm going to do is I'm going to put the coefficients together. Those are the numbers in the front. So I'm going to put those together. And then I'm going to take my x's and I'm going to put those together. So if we multiply 6 times 4, we get 24. Now remember, when we multiply exponents with like bases, we keep the base and we actually add the exponents. So that's going to give us 24x to the 6th. Now number 18 is a little bit different. On this one, we've got a power on the outside. So notice there's no plus or minus signs in here. That means everything inside the parentheses gets that power. So negative 4 gets raised to a power of 3. X to the 5th gets raised to a power of 3. And y to the 7th gets raised to a power of 3. Now negative 4 to the 3rd, remember that means negative 4 multiplied to itself 3 times. That will be negative 64. And then remember here, for our exponents, we are going to multiply. So here we multiply exponents, because it's a power to a power. And over here, when you see the base twice, that's when you add the exponents. So notice here we only see the base once. So I think of this as 3 sets of 5, and I know that 3 sets of 5 is going to be 15. And then I'm thinking of this as 3 sets of 7, so that's going to give me 21. All right, and then this is your final answer. Now for 19, we have a fraction. So the first thing I would do is I'm going to think about it in 2 different parts. I'm going to think about 6 over negative 2 and x to the 4th over x to the negative 5. So kind of splitting it up a little bit like I did on number 17. Now if I start with 6 over negative 2, I know that that just simplifies to be a negative 3. But when I move on to my x's, remember here we are supposed to subtract the exponents. Okay, and it's always top minus bottom, so that'll be 4 minus a negative 5. So I keep the negative 3, and then 4 minus a negative 5 becomes 4 plus 5, and that gives us a positive 9. All right, so number 20 is definitely our trickiest, and I may run out of room here. I may have to go up to the top a little bit. So just like I saw on number 18, I have this exponent on the outside. I don't see any plus or minus signs in there, so what that means is everything in here gets raised to the 3rd power. So I'm going to take a second to write out that step. So 2 gets raised to the 3rd power, x to the 4th gets raised to the 3rd power, y squared gets raised to the 3rd power. Then I go to the denominator and I do the same thing. 3 gets raised to the 3rd power, x squared gets raised to the 3rd power, y to the 5th gets raised to the 3rd power. All right, so now I want to clean that up. 2 to the 3rd is 2 times 2 times 2, so that's 8. Remember, this is where we multiply exponents, so x to the 12th, y to the 6th. On the bottom, 3 times 3 times 3 is 27. I get x to the 6th, y to the 15th. So now this problem looks a lot like number 19. I actually can't reduce 8 over 27, so that's going to stay exactly the same. So think about it this way. I'm going to keep the 8 on top. I'm going to keep the 27 on bottom. I want to subtract the exponents like I did a minute ago. So we're going to put the x's in the top, and we're going to go 12 minus 6. Then we put the y's in the top, and that'll be 6 minus 15. All right, so keep the 8 here and the 27 on bottom. That's going to become x to the 6th and y to the negative 9. Now remember, we're not allowed to have negative exponents. So we're all done except for this one little part. And what we do with a negative exponent is we take that whole piece and we're going to move it to the other part of our fraction. So in this case, the bottom. Sorry, I'm going a little weird on my direction here. So once again, the 8 stays on the top, the 27 on the bottom. I'm going to leave those x's where they are because they have positive exponents, but now I'm going to put the y's on the bottom, and that changes that exponent to a positive 9, and that is your final answer.